Hello, it's Sean, and welcome back to this channel. This will be part 2 of our restoration series on this All-American 5 Zenith radio, model number 5D810Y. I believe I called it the pacemaker, although I mistakenly called it the peacemaker at one point. But either way, like I mentioned in the first video, I don't have much experience working on All-American 5 tube-based radio systems, although I have worked on many transistor-based radios over the stint of my career. So when it comes to comments in this section, and I believe there were a few comments in the first video, it's actually very helpful for me getting perspective from people who've most likely worked on these systems before. That being said, if you are new to this channel and you've enjoyed this video, please consider subscribing. Also, if you're returning to this channel and you're liking the content and you like this video, please consider giving it a thumbs up. Always going to encourage commenting in the comment section. I try to respond to all of them, and I appreciate the comments and the feedback. That helps me better my channel. Additionally, if you haven't heard in my other video, I have registered Having Fun Repairs as underneath a sole proprietorship in the state of Oklahoma, so I can operate underneath this name as a business. If you want to know more about the business, please go to my Google site, link in the description. And it covers how to seek a repair from me, what the steps to get that accomplished. It will cover a little bit on data recovery and restorations if you're seeking those items as well. And there is also a donation link in the description, so if you prefer to just donate, I will highly appreciate it, any and all donations, and it will get used to go back into different projects, i.e. different things that I plan to work on, whether I need components for repairing, etc., etc. That will go to that content. It won't go to any content where somebody is paying me for a service. I'll put it that way. But that all being said, let's get started. We're zooming into this restoration. I want to address a few things that I uncovered looking more closely to our IPB here. Primarily, take a look at this bumblebee cap you see right here. Okay. Now, if a lot of these capacitors will get replaced, and I'll go over that in a little more detail later on. But I primarily want you to first, and I know it's hard to see on this graph unless this schematic, unless you have one, or diagram, unless you have it downloaded yourself. Look at where it's terminated on the upper end, and then if you follow the wire, you can see where it's also terminated to over here. Now looking at the bottom of our chassis, and the same orientation as what we have on the diagram, does this look like a bumblebee cap to you? And if you answered no, you're absolutely correct. It looks like that capacitor was replaced with a different style cap. I think this one might be oil filled. I'd have to double check that. But it's also rated for 0.05 microfarad. Which is slightly higher than the original capacitor, I believe. Yeah, number 7 should be 0.07 microfarad, so it definitely is higher. That is something that we'll need to address, and obviously indicates a little bit of service history to the system. I also want to address where it's terminated to. So we have the same starting point, but we have a different end point. This one's coming up here to one of the legs off of this tube. But if you follow that wire that's also attached to this post around, it goes from a black wire to another termination point to this brown wire feeding through here. That's terminated to the point where the old cap would have been soldered to. Now in my head, you know, no matter if it's here or here or here, electrically it would all be the same. However, say that there was a short in this radio, more specifically this capacitor was shorted, and a whole lot of current was drawn through this short, right? But I would think if this capacitor was a short, and if wires were to start to get hot, then if this was terminated here, then I'd only be burning up the wires as it leads to our potentiometer here for turning the system, or what is this, our switch for turning the system on and off, and yes, a potentiometer too, maintaining our volume. Sorry, this potentiometer down here. So in that case, you would honestly probably save the wire that's leading up to this post here. So when we replace this, I am going to replace it and re-terminate it down to its original termination point. Secondly, our rectifier is shown to be, or sorry, our power output, number 4, is shown to be a Zenith part number 50L6 GT. Okay, I believe that's what's shown right here. However, what we actually have is a 35L6 GT. Well, if I go to, is this a Sylvania tube? It is. But either way, if I go to this tube conversion chart, which I was able to download online, we can see that a 50L6 GT can be substituted by a 35L6 GT. However, we have a little indication here on the B column, says fill voltage. Well, let's check the note. B note says this means that the heater voltage of the substitute tube is different from the required type. In most cases, this can be taken care of by changing or shorting out a section of the series resistor. In cases where the resistor is in line, in the line cord, this is difficult unless the total voltage can be increased enough to make a line resistor unnecessary. In transformer and auto sets, this indicates that the series resistor is required to drop the voltage to that required by the substitute tube. So that is something that we are going to have to annotate. I need to be able to check to see if the voltage is sufficient for this tube, as well as determine if there are any resistors that have been changed or added to this system to support swapping out of that tube. Now, if there are not any additional resistors or removal of resistors to affect that voltage, then I may run it with this tube, but more than likely I might also be looking for a replacement. And lastly, I want to address a big elephant in the room. What happened to the speaker? Well, if you recall in the first video, I put a little bit of lightweight machiner's oil on it. And it did actually, in fact, give a little more life to this cone. Now, I did let it sit over time instead of just, immediately trying to do any work on it. So I would recommend if you do use an oil to condition the cone, that you apply a very thin amount and then you just let it start to dry out. Okay. However, I left a ballpoint pen next to this radio, and my 2-year-old daughter had access to get her hands onto the desk where I left the radio and the ballpoint pen, and proceeded to poke a bunch of holes into the cone and tear a significant chunk out of this side over here. So what I had to do is use some E6000 or B7000. What did I use? B7000 to kind of fill in those ballpoint pen holes and small tears. B7000 is pretty pliable. Hindsight 2020, I wish I had some rubber cement. That would probably have been better. You don't want to use a glue like a super glue that's going to be really hard, because that's definitely going to change the sound that your speaker produces. But at this point, the sound's going to be changed regardless. Remember, a cone is there to vibrate at the frequency of the audio signal as it comes through the coil, right? You have a, if it's a permanent magnet speaker, you have a magnet, and as the audio goes through the coil, that magnet and is attracted to the magnet, the cone is going to move up and down. and vibrate at the frequency that's coming through. That's how you produce sound. I think I explained this a little bit better and in greater detail in a previous video in the past. But what I had to do on this side is I had some, I wouldn't call it a paper towel, it was more like a shop towel. And for those of you who know what shop towels are, the paper mesh or woven fabric is a little more, is slightly thicker, a little more sturdy. And so I was able to cut some small pieces out, and then I laid them over top, and I used something called Montage, which for arts and crafty type people, you know, you can pick up at Hobby Lobby and many other arts and craft stores. And then I put a light coating of Montage over the top in order for this to now become essentially part of the cone. Now, it is a Mod Podge dries like a more standard glue. It's not rubber like B7000. So this is a lot more stiff. So we're going to see how it sounds, and if it sounds completely terrible, then I'm going to have to source a speaker and get this replaced. But for now, at least I don't have a torn speaker anymore. And then when we do get this radio to where I'm comfortable with plugging it into an AC power source, I'll do that, and we can listen to it for a bit. I'd also like to address a comment in the first video. I think Ralph J had some comments that he mentioned, and they're relatively good questions. One question he asked, and I have no qualms with answering it, and really it was, hey, do you mind explaining this in your next video? Some viewers may not know, but it is in part 2 why you need a carrier and an IF. So essentially a two-part question there. Let's address why we need a carrier first. To address that question, you need to have some kind of background in understanding frequencies and wavelength. Typically, a lower frequency will carry over a larger distance, i.e. when your neighbor's throwing a party and you hear all that boom boom coming from their boom box, you're hearing the bass, low frequency, you know, down the street. You're probably not hearing the singing or the frequencies out of the instruments because they're typically a lot higher. But that boom boom you're going to hear quite a bit, right? Well, when we speak, we typically speak between 300 to 3,000 or 6,000 hertz. That's kind of a standard, right? Now a lot of people's voices vary in ranges lower and probably ranges higher as well. So you would think, well, why wouldn't my voice carry, you know, miles and miles and miles down the road? Well, your voice is obstructed by anything in front of it, okay? It is very low power. And I don't know about you, but even though I've had training with being a parent with kids, you know, I could raise my voice, but it's just not going to carry very far. And also, I don't like raising my voice if I don't have to. So how do we circumvent voice being blocked by essentially anything that's directly within our path? Well, you do it by essentially modulating that voice onto a higher carrier frequency. A higher frequency traditionally won't travel as far because the wavelength is a lot shorter. However, you can amplify a higher frequency signal, and higher frequencies can travel through space at the speed of light and are not as obstructed by the Earth's atmosphere. So that's good news for us. That means that now my voice, which can't get through one wall in most cases, I can get it onto a carrier frequency and in the speed of light get it miles down the road for somebody to listen to. That's a good thing, right? So what about an IF? Well, if we got that carrier frequency coming in, why do we need an intermediate frequency before we get to audio? Well, I thought I kind of covered this in the first video, but maybe I didn't make it clear enough. You want that intermediate frequency, that in between, because the primary purpose of it is to create selectivity. Okay? So when you have a frequency, you have all these adjacent frequencies, right? And but all you want is one frequency, okay, to make it through a circuit and to extract out that audio, whether it's analog audio and older technology like this, or digital audio in a newer radio. Again, even if it's digital technology, it's always converted back to analog as it comes out the speaker. So kind of something that I laugh at when I hear of a digital audio system. You know, yes, they have higher fidelity, but still analog audio that when it comes out, because we're not going to hear bits and bytes, to be honest. Now, an IF itself, as indicated in the first video, is much lower than your carrier frequency, and it's going to be somewhere between your baseband frequency and the carrier frequency. Secondly, when you have an IF frequency, that IF is constant. So when my carrier frequency comes in and changes, at least I have an intermediate frequency that's constant for where we detect the audio writing and pull it out and pull out that audio and then slightly amplify it out our speaker. If that IF, if we were just to go from our carrier frequency and pull out the audio and put it to our speaker, we're going to have a lot more noise because that carrier frequency, as soon as I turn the dial, is changing. I need that constant IF in order to give myself a lot more, I get maybe the best term for this is fidelity. But anyways, when you hear IF, two things should come to mind. Heterodyning and super heterodyning receiver systems, okay? And without that constant IF, you'd also have to design your receiver in a manner in which you would have, let me think about this, different receiver circuits to cater to all the different transmitting radio stations. Man, that would be a nightmare. And it would probably be a very massive radio. Could you imagine something, I don't know, 8 times the size of this with all those components? Yeah, what quite a bit of waste and components and electronics just to be able to hear something that's being shot out over the airwaves. Now we're going to move into what I'd like to tackle next. Capacitor replacement. Now, this might be boring for some of y'all because, you know, in pretty much every repair video you're always hearing, especially from me, capacitor needs to be replaced. Capacitor, 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 capacitor. And they're usually the biggest fault in any electrical circuit or PCB. Man, they create issues. That being said, we do have some unique things to consider here. I will not be replacing the mica and the ceramic disc capacitor. Typically these last a very long time and will not be an issue. We have one here and another sitting right here. They will stay in the system and hopefully they have not deteriorated to the point where they need to be replaced, but we'll find out about that a little later on. Now, the original bumblebee cap was replaced. Like I said, I believe this is an oil-filled cap. This needs to come out as well. Okay, these things get super leaky over time, and that's an issue. I wouldn't be surprised if this capacitor was very leaky and essentially acting as a resistor and you know, more current being drawn inside this radio than what needs to be. We also need to replace these paper foil caps. We've got 1, 2, 3, 4 paper and foil caps. They're coated in a wax as well, which is kind of it's kind of nasty in my opinion. More than likely they're bad. The dielectric or the paper and the foil wears down over time and they begin to short out inside and all kinds of nasty things happen. But what is interesting about these type of capacitors used in this era is you have an indication on a lot of them here, if you can see that white band. Maybe I'll zoom in a little bit here, make this easier. All right, can everybody see this white band here. And then on these, you would have a black bar, kind of hard to see on this one. It's somewhere on there. We'll figure it out later. But those indicate the outside foil of the capacitor. And the outside foil is the one that needs to be go to the side that is closer to our neutral or our ground line. Okay. Now, why do we care about the outside foil of a capacitor? Well, that has to deal with noise. Okay. And I'm going to show you a few techniques when you get capacitors to these actual capacitors that you can still procure newer actual capacitors. Sometimes you're not going to find a exact like for like, such as you might not be able to source. This should have been, and I think I mistakenly said 0.07, 0.047 microfarad at 400 volts was the original Bumblebee that was in here. Okay, this one's 0.05 microfarad at 600 volts. You might not be able to find a 0.07 400 volt cap, in which case you need to look up the tolerance in your service history to see what you can use within tolerance close to that 0.047 microfarad rating at a voltage rating of 400 volts. And if you can find something that's within that tolerance, then by all means you should be able to use it. But yes, these will be coming out. We will be replacing them. That is what we're going to do next. And I want to show you how you can determine the outside foil of newer capacitors, because they don't come marked like they do in these old capacitors. And there's a reason for that. In this older radio technology, what we have is point-to-point soldering. Okay, there's no PCB here. This is all point-to-point, so it's easy to tell when you have a marked outside foil on your capacitor where they need to be terminated to in circuit. Not so much with printed circuit boards. And it's less common to use these type of capacitors, so there's less of a need for those type of markings. So let's do that next. Let's pull out a few capacitors, and I'll show you a few techniques for determining the outside foil. I'll show you my primary technique used using some of the test equipment I have, and then I'll try to show you some alternate methods that you can potentially use at your house if you don't have the same test equipment that I have. So I got my stack of capacitors here and my list of capacitors that I needed, and in all honesty what I did was I got two different brand names of every type, essentially, or two different construction material or different dielectrics of every type, mostly just because I needed a little bit of stockpile, and probably some people are going to hate me for taking up a bit of stockpile from Mauser, but also in case if I do some work like this again, I would like to know when these capacitors are in circuit, which ones give you better fidelity, maybe less noise to the speaker. So we'll try some out a little bit later on. But for now, because we do need to replace them, I want to focus on these first two over here. And in all honesty, these are both polypropylene capacitors, both rated for 0.047 microfarad at 400 volts, and I think they are both plus or minus 10% is the tolerance. I'd have to go back and look at the data sheet, but obviously two different manufacturers, two different styles, one being white and another being yellow. I want to say I got less of these because these happen to be more expensive than these ones over here, But, you know, just one of those things, I suppose. Well, I've got the yellow one on my desk, and you're probably wondering why there's my SIGGEN's up there in the right-hand corner. I'll explain that in a second. Now, I understand most of you might not have a signal generator or an arbitrary waveform generator, so we'll have two other methods I'll show you for determining the outside foil on these type of capacitors. Now, at my local hardware store, I did go ahead and purchase a Fox and Hound. Sometimes these two devices are referred to as that, or a audio generator, tone generator, and inductive amplifier. Now, these are common tools for people in telecommunications. They're relatively inexpensive and fairly easy to come by. Now, I'm going to set this one aside for now, and primarily I'm going to be using this inductive amplifier and the SIGGEN that you see in the upper right hand corner. Now, if you're looking at the signal generator, you can see that my frequency is set to 1000 Hertz and an amplitude of 5 volts. For testing purposes, I'm going to go ahead and decrease that voltage just a little bit. Let's start out with, say, 2 volts. And I kind of want to change up the waveform. Let's do I want triangle? What's a good one? Square? Yeah, we'll do triangle. I think that would be perfectly fine. Okay, so a 1000 Hertz tone in a triangle wave shape versus sinusoidal, kind of what you see on output B or 2, which I'm not using. An amplitude of 2 volts. That'd be. And now I'm going to turn on this inductive amplifier, and this is attached to channel 1. Actually, when I touch it, you kind of hear that signal being induced into me. That's interesting. But anyways, I want you to take notice of something. There goes that 1000 Hertz signal. And the reason why I changed it from a normal audio waveform to triangle waveform is to kind of give it a little bit of a distorted sound. Here, we can switch back and forth and I can show you the difference. Might be harder for you to hear the difference through this recorded video, but there definitely is one. Yeah, the triangle has a little bit of a sharper sound to it. But you notice that the audio comes over one of these alligator clips, but it's not here on the other one. It's because the external side of the BNC connector is ground. It's not audio over both sides. This is carrying my audio, this is not. Okay? Now, what I'm going to do is connect one side to each leg of our capacitor. If I can get this to lay down without having to put my fingers on it, that would be better. And then I'm going to listen. And then what I'm going to check for is I'm going to swap these alligator clips around and see which side, when they're terminated, is louder. So I am using my ears as much as possible during this test. I feel like this connection is pretty loud, and it was less loud the other way, so I'm going to swap them out again. And we did get a lot quieter with the leads reversed, these alligator clips reversed. Now, if you were running into an issue where it just sounded super loud on both sides, depending on the type of capacitor you have, then drop down the amplitude of your signal that you're generating. So now we have a 1 volt signal going in at 1000 hertz. And then let's see what it sounds like when I swap them around. And this way we have no difference in that sound as soon as I attach my ground lead. It's still loud. Ground lead goes on and it's practically quiet this way at a lower voltage coming out of the SIGGEN. Now, why is this important to me? Well, remember what I said? Having that capacitor put in circuit is important because it helps eliminate noise. Well, now I know which side of my capacitor is the outside foil, and I can thus... Oh, where's my Sharpie marker? Here it goes. Take my Sharpie marker, and the one that my ground lead was on, I'm going to mark that with a little black dot. That is my outside foil. Now, you might be asking, well, since you determined the outside foil of this capacitor, and when you look at it, maybe I can zoom in just a smidge here. There we go. We have clearly defined annotations on this capacitor. I can read it left to right. Does this mean that every capacitor that's stamped with your wording left to right, the right side of the wording, is going to be outside foil? Absolutely it does not. You'll need to check every single one because the factory is going to stamp these however they go through the roller or whatever machine is used for pressing on the values. Okay, so I have to do this for every single capacitor in this bag, in that bag, and all the bags you don't see that is over on the left as well. Alright, so what other methodologies can I present to you to accomplish the same task? Well, you might be able to get by with using your tone generator. Let me turn it on real quick. I've got it set to 800 hertz. We'll kick it up to 1000 hertz. However, if you use this method, you have to give an additional consideration. Remember I showed on our other pair, one carried the audio, the other one was ground? Well, with the tone generator, both leads carry the audio, and that's not going to work for this application. So I need to disregard one lead, and I'll need to use a different lead to have a ground. Same principles apply though. I will hook one side up that's carrying the audio, sure, and I have a good connection, and I'll hook the other side up that is my ground, and then I'm going to listen. Right now that sounds pretty quiet. I remove the ground lead, it's loud. Hook up the ground lead, and the audio lead, it's loud. Rehook up my ground lead, and it got quiet again. Let me drop the frequency. And you can marginally tell a difference. I wouldn't say this is a good method for this capacitor, but it might work with some other capacitors. Let's do another test. So here's our new capacitor to try out. This is a 47 nanofarad polyester capacitor, rated for 200 volts. Again, the method with the tone generator. Let me turn this up a bit. Yeah, I can definitely tell a difference. It might be harder for y'all listening in, and I realize this is dragging on, but it mostly sounds to me that proper orientation, that this side over here, let me pull this away, knows how it gets louder the further away I get from the capacitor. You should keep your inductive amplifier right over top of the capacitor to do this test. But we can still test this out if I was to turn my signal generator back on instead of just using the ground. Let's see if this is in fact working. Okay, got a 1 kHz tone going through at 1 volt. That sounds pretty quiet. Now louder. Now it's staying loud this direction. And it's definitely quieter this direction. So we've proven that this method can work using this device, but not with both legs because one side needs to be ground. However, your mileage is going to vary depending on the type of capacitor you're testing, and the reason being for that is because you can't control the amplitude of the audio coming out of this tone generator. Now mine's a little bit more fancy. I can change the frequency, which kind of helps me out a bit, but I can't change the amplitude. And if I can't bring that amplitude down, in most cases, I need a pretty low amplitude audio signal. I'm not going to be able to detect that audio difference as well as I should. Well, let's also say that you don't have a tone generator or an inductive amplifier or an audio, a signal generator or function generator. Then what can you use? Well, here goes a low-key hack for you, if I can put it that way. Remember the amp that we did a restoration on? And this phone that I repaired, the audio and everything on the bottom a while back. Screen's about to die. Well, say hello to our tone generator and our inductive amplifier. Now, I have my capacitor hooked up to the cord that's going into the cell phone. And just that way you have a visual. The tip is going to carry the audio, and then this is going to be your ground. You don't hear anything, okay? Now, with that out of the way, because I don't need it anymore, I'm going to take this, and then coming out of the front of my amplifier is another cable, which I've wrapped around and stuck the tip right there. And now I'm going to lay this capacitor over the tip. Could you hear that 1 kHz tone? Okay, now I've swapped the capacitor around, and you can see that the side that we marked as the outside full is now on the ground side of this plug. And again, I'm going to lay it up to the tip of our phono plug over here. Now, I still got noise, but I'm hearing less of that 1 kHz tone. Listen very closely, and then I'm going to pause the video and swap them around. In 3, 2, 1. Fully swapped around this time, and you can hear that 1 kHz tone practically loud as day. And the great thing, if I didn't mention it about this method, so long as people aren't ringing up your phone or text messages coming in, you shouldn't have all that buzzing sound that you heard maybe a few seconds ago. But I can change up the frequency, and actually I have amplitude control as well by simply increasing or decreasing the volume of my phone. So if you don't have a frequency generator or a arbitrary waveform generator or a audio generator period, yes you do. It's called your mobile device. And then most people are going to have some type of amplifier of some sorts, I would think, or could probably, you know, go to a friend's house and borrow one. But there, that's your low-key hack, and it will work the same with other capacitors as well, and probably work better than that second method that I showed you. Well, just off of camera, I decided to get the chassis just slightly more cleaned up. You can see that it is slightly more polished. And yeah, so we're going to move into replacing the capacitors. Now, I mentioned the outside full being associated with the bars. I want you to also notice, and I didn't mention this previously, so I'm going to make this quick. Sometimes they will be marked with ground, like here it actually says GROUND, and so does this capacitor right here. So as far as orientation goes, that needs to be considered. Now I'm going to swap out these capacitors and then explain a little bit more what it went into this as soon as I'm done. So I wanted to stop for a second and just deconstruct this CAN capacitor, and probably gonna get quite a bit of hate for what I've done, because you can see that well, pretty much cut it open, but not to worry too much, because I did save this insulator, and I am going to mount this back to here and get it on there, especially after I get the inside of this can cleaned up a bit. But the reason why I did that is because I really did want to see what this capacitor will look like on the inside, and that gives me a personal learning experience, and kind of just satisfies my curiosity. So even if I get hate, I did this for myself, and of course I'm gonna have to find a way to somewhat make it look decent when I'm finished. But anyway, so here you go. This is a Sprague CAN capacitor. It has a 50 microfarad at 150 working volts DC, 30 microfarad at 150 working volts DC, and the CAN is your common negative. Okay, so our common negative would be this guy right here, which did attach to this post right here, which is the common negative. Anyways, so these are going to be our terminal posts for our replacement capacitors. So if I could orient it a specific way, here we go. These as well are Sprague electrolytic capacitors, and they're axial. These are actually marked positive on the end that's positive, and if you can tell by this video that the positive side is actually indented all the way around the capacitor itself, so you can tell without having to hook it up to what we had to do with our previous capacitors which side is positive and which side is negative. Now I've got two Sprague capacitors sitting here. One's a 30 microfarad at 150 volts, and another one's a 50 microfarad at 150 volts. These things were not cheap, to say the least. Anyhow, I'm going to clean up my mess I have on my mat, and we'll get busy again. Okay, now that all of that is over with, let's do a little recap on everything that was just done, and hopefully somebody else who's tackling one of these radios for the first time can learn from some of the things that I will go ahead and say I feel like were mistakes I made going into this. Now, I had already paused the replacement of capacitors just to go over the can capacitor and showed y'all the two caps, how they were interwoven inside of that can. It's pretty unique. But you can see the replacements went longitudinal right here on the chassis. That's where I put them. Same value that was on the can versus the value that you will see here recorded on the diagram. Now, why did I not do the value of 60 and what is that, 20 for a total of 80? Yeah, 60 and 20 is what's recorded here. Well, because the can that was in there was a 50 and 30, and I don't know, either somebody had replaced this can once before, or that was put in maybe because we have a different what is that? Yeah, instead of the 50 L6 GT, we have a different tube right here. Now again, I don't entirely know, but I'm just going to keep it at that, at what is rated on the can, and we'll test out the radio, power it up, and just see how it works. That being said, moving down the line, see, our next capacitor was number 7. It's a 40.047 microfarad, rated at 400 volts. You will find it right here on our diagram. That capacitor was not that guy, this guy right here, the one that was that death cap, this dude right here. And that somebody had swapped out a 0.05 rated at 600 volts. Let's actually test that cap out just to see what we're getting. We get a reading of 60, 61, 62 nanofarads. So you would think that this capacitor is just probably providing more capacitance than what it's rated for, but no, that's not the case. Most likely this guy is incredibly leaky. I don't have a leakage tester, so that is my assumption. And that, and watching many videos where people work on these types of devices, these types of radios, that seems to be the common denominator. So that one was replaced, and we ran it from here to here. Now, number one thing, okay, I wish I had oriented the 30 and the 50 in opposite directions based off of how I had to pull out these wires and run everything over again. Now, I would had preferred to keep the wires through their factory routes, and I don't know if by running them through a different direction and over top of, say, this speaker wire, that's what this red wire goes to. It's going to go down to the output transformer for the speaker. I'm not sure if we're going to induct any noise onto anything, especially with this one coming from our amplifier essentially, but we'll see how it goes and see. Hopefully it still sounds okay. We don't have too much noise, but that's all I'm going to comment on that. I would just say, hey, when you are swapping out capacitors for your can, be very sure how you're going to orient them and take note of where all your previous wires and components, resistors, etc. are laid out, so you don't have to do so much reorienting of everything. Now I will say I wanted to replace this resistor right here. This was a 1K ohm resistor. I believe this is going to be a 1 watt resistor as well. I only have half watt resistors, so no bueno. This measured slightly less at 980 something ohms. So I may have to go in here at a later time and replace it. You can tell that this resistor as well, it's been baked a lot. Lots of current going through here, cooking it. At least that is what I think has occurred. But anyways, yeah, main takeaway, just anytime you're swapping out caps for your can, be very careful how you orient them and take note of the length of wires and other components and how everything matches and fits up to what was previously there. Moving on. Number 8 was a 0.02 capacitor at 400 volts. Number 8 you can find right here on our diagram. And if we were to look at IPB2, which is what I've named this, number 8 is this capacitor right here. Now, here we go. This one I swapped out with a 0.022 microfarad capacitor, rated for 400 volts. Now, capacitor rating was plus or minus to 10%, excuse me. And so that 0.022 microfarad capacitor is at the very cusp of that tolerance. Now, could I have replaced it with something closer to 0.02? Potentially yes, but I could not find Mauser or DigiKey a capacitor in the same style that was in stock, and so I just went with this because that was what was available, and because it's still right there within the tolerance, even if it's on the higher end of that tolerance, like literally right on the edge. Now the 0.202, where were we at? It's right here. That's this guy. At least I think that was this guy. Yeah, it was this guy right here. And we will check it just like the previous one. And we're at 88 nanofarads. Ooh, not even close. So we can definitely say that that guy has gave up the ghost. Good thing that we replaced it. Moving on to number 9 was a 0.01 600 volt capacitor used for audio coupling. Number 9 we could find right here on our diagram. And where is it at? Here. Oh yeah, this guy sitting right here. Okay, so our 0.01 at 600 volts is located right here. And it was replaced with a 0.01 microfarad at 630 volts. Yeah, and we're way off. So, good thing that guy got replaced as well. Hey, now we're looking at number 10, which was a 0.05 at 200 volts. Number 10 could be found right here. There goes number 10. We can see it right at the beginning of our diagram going to the B minus. Number 10 on IPB2 was right here. So I replaced number 10 with a 0.47 nanofarad orange drop style capacitor rated for 200 volts. You can see it right here. Of course, 47 nanofarad is not too far off from 50 nanofarad or 0.05 picofarad, microfarad. But again, it was a sourcing of parts, and could I find those parts and be able to replace them? The closest I could get was that orange drop capacitor. Now it is within the limit on our tolerance, and so I think we should be safe. But again, truth will be told once we plug everything in and see what happens. Alright, so this one is reading almost 400 nanofarad. Way off again. Okay, before I get to number 11, number 12 was not replaced because it was not physically in here. We'll see if that causes any issues down the line. But if I need to, it's just another orange drop capacitor, and number 12 can be found right here, and it's just taking two of these guys to our B negative. Now I also did not replace 13AB or 14 because those were our mica and ceramic capacitors, and as I mentioned, they typically do not break. There goes our ceramic disc and our mica capacitor down there. So hopefully they are good. But I did swap out our line isolation capacitor. Now it's labeled as 0.07 microfarad at 200 volts. Number 11 can be seen right here, at least on this diagram. Looking at this IPB, number 11 is right here. And that was this guy that I took out from right here. But instead, I've replaced that with a safety cap. not just any safety cap, but a 0.01 microfarad X1 Y2 rated safety cap at 440 volts AC. Now, there is a reason why I chose this specific capacitance style and voltage. X1 Y2 are very good across the line safety caps or line to ground safety caps. So when it fails, it's going to should fail in a open, not fail in the short. Thus, we're not taking our B positive directly to, or ACN directly to the chassis, in which case that would give us a true hot chassis, which is very, very dangerous. This guy needed to come out as well. So yeah, no electrocuting ourselves and no hot chassis. Let's check this capacitor, and we're at 500 nanofarad. Again, super far off. It's reading like 0.5 microfarads instead of the original, which stated 0.07. Yeah, it's a good thing that guy got taken out as well. Now, why did I swap this for a 0.01 microfarad rated safety cap? Well, I'm just going to be honest. Primarily watching YouTube channels, specifically watching Mr. Radio's YouTube channel, if this is going to focus. Hopefully that's focused a bit now. But he goes over this and with pretty much every one of his radios and in pretty good detail. And if there is one thing I've learned is to trust the guys who have been there and done that. So when they make a recommendation, I pay attention. So what else can I say about this radio that's been done? Well, to finish up on the capacitors, I did make sure that on the legs as much as possible to cover them in either heat shrink or the fabric that was on previous ones, in hopes to keep anything from shorting out against the legs of those capacitors. Again, I can't reiterate this enough. Just make sure you're aware of how long the legs off of your capacitor are going to run, and orientation, because all that's going to play into how nicely this is going to look once you're finished. Over here, in my opinion, could be a lot better, but I've learned. We've also replaced our power cord with a 2-prong cord. Obviously, one end slightly wider than the other plug or pin on the plug. So it's like it's a modern 2-prong plug. We'll just put it that way. The wider end is going to be our neutral. The thinner is our hot. Okay, so I had to make sure that I wired it up exactly as such in the diagram. I also put a knot on the inside to give us a bit of a strain relief, so we're not pulling anything internally. Hindsight 2020, I wish I had gotten a 2-prong plug that was a little bit more flexible than this one, but you know, you live, you learn. It's my first time attempting to completely restore a radio as such. Okay. Also, I used some electronic cleaner and sprayed inside this potentiometer and worked it back and forth, and it has freed up So hopefully we can now power up this device. And then as far as the can goes, now again, not the prettiest, but I did put this insulator back down and 2-part epoxy the can back on top of it with the label facing outwards, so it's easy to read that label, and reaffix this to the chassis. Even though nothing inside of here is being used, it's been completely gutted. Hindsight 2020, now that I know better and have satisfied my curiosity, I'll just leave these alone in the future and end up just cutting the leads underneath and resoldering things. That being said, we still got quite a lot to do, but we could attempt a first power up with those capacitors replaced, and hopefully nothing catches fire. Alright, y'all are gonna get this at the same time I am. Radio going to dim bulb tester, going to variac, going to isolation transformer. Let's turn on our isolation transformer. Let's turn on our variac. And I'm going to increase that voltage up to about 80. Okay, let's turn on our dim bulb tester. There we go. We're getting 78 on there. And let's turn on our radio. And we've got no sound whatsoever. Give it a few more seconds and it started to come alive. This is awesome. Looks like we have filament on all of our tubes. Let's increase our output. See, either we have nothing on the AM band, or I've got other issues with this radio. Okay, I got all the lights turned out just because I want to show y'all some things. Currently got my SIGGEN set up for 1400 hertz, and then modulated 9% at 1K hertz or 1000 hertz. Running that all the way over to the antenna. There you go. You can see that there. And feeding into the radio. Now I'm turning the light out so y'all can see that that dim bulb tester is working. You see the filament is just slightly illuminated. I mean, I'm not drawing a whole lot of current right now to this radio. But here goes that 1 kHz tone. And of course it doesn't sound right. Because I think either there's another issue with this radio, or it's just hugely misaligned. And I know these bulbs look like they're glowing super bright without the light on, especially that back one. But that's just the phone adjusting for that luminescence coming from those bulbs. They're really not that bright. They're not much brighter than that, although they are brighter. But we'll change that 1 kHz tone to an 800 Hz tone. And you can hear the different pitch as well, but that doesn't sound super clear to me. It's not what I would call an 800 or a 1 kHz tone. So we still got a lot more to do. Finally, some hope. Just playing around with the tuner. So tuning off freak, you can hear it more. You lose quite a bit on your volume pot. Interesting. So maybe this radio just needs a good tuning. Well, here goes me from the future, just a tad bit. But listen now.
And brain damage. She sings about all of that too. Here she is in Substance. What's her conclusion? Her conclusion is that the values that she was never given, values of which she was deprived by an entire industry that runs on sex and drugs and hedonism, it's those values lies in embracing precisely values.
Yeah, speaker's got a bit of tinniness to it. Gonna have to get it replaced, but man, way better reception during the day on AM. So we'll still go through an alignment on it, but I didn't want to leave this out. Well, I cannot tell you how excited I am just to be hearing something coming out of this radio. I mean, there's still so much that needs to get done, but at the same point in time, I feel like I've walked over that very specific definitive line or milestone in this project. So I'm incredibly happy. I'm still concerned with what we are hearing coming out the speaker, not just because of the speaker itself and the patchwork I've had to accomplish on the cone, but remember the original tube was swapped out for a 35L6 GT, and according to the Sylvania book we looked at, there are some voltage considerations and stuff that needs or maybe has been or has not been addressed when you swap that tube out, and that could be a cause, since it is our amplifier tube audio, for why the speaker sounds overdriven and incredibly distorted as the volume is increased kind of beyond the midway point. I wouldn't think that is a characteristic of this radio particularly, but it is what it is. Again, might need to align it. The tuner needs to be restrung, still need to do that. The chassis has quite a bit of work to do as well. And there are a few other components that look like they're very tired and baked a bit that I'll probably end up replacing. But that being said, hopefully you've enjoyed part 2 of this restoration. If you're new to this channel, please consider subscribing. And please also, if you've enjoyed this video, consider giving it a thumbs up. Comments always welcome in the doobly-doo down below, especially if you've worked on this type of radio before. Like I said, this is my first time, so leave me comments. It helps me learn and it helps everybody else learn as well. And again, having fun repairs. I can do business as Having Fun Repairs in the state of Oklahoma. So if you're interested in repairs, restorations, or data recovery, please see my Google site link down in the description and follow the business. There's a business subpage to the main page, but anyways, it will walk you through how you can get work accomplished by me. And then if you want to donate, there's a PayPal as well. All donations I appreciate, and they go back into producing content such as this. That being said, thank you for watching. Take care. Goodbye.
Bark?